Lesson 12, Density. This is going to be the last lesson underneath the basics category. After this, we're actually going to start some true physics. So let's take a look at our objectives. Our first, as usual, is to define what we're talking about, in this case, density. You will also want to be able to utilize the formula for density to calculate either the mass, the volume, or the density when given the other information. So let's take a look at our definition. Density is the ratio of a substance's mass to volume. As a ratio, you know that ratios are a fraction, something like 1 to 2 or 5 to 6. As a ratio, it's, remember, a fraction, which is division. So another way to look at it is how much matter something has, its mass. Remember, per means to divide, which is what we do with a fraction. How much space it takes up, which is volume. As a ratio, it is going to be constant. So once you know a substance's density, it is not going to change. For example, if something had a ratio or a density of 1/2, 1 to 2, that ratio will remain constant. So that tells me that the mass is 1 and the volume is 2. If I increase the mass to 2, then the volume has to increase to 4, or 2 to 4, which still gives me a ratio of 1/2. If the mass increased to 5, then the volume would need to increase to 10, so that my ratio still stays the same. The fact that the ratio, or the density, stays the same allows us to identify substances, because every substance has a unique density. As a ratio or a fraction, we can see what we get for a formula. D represents the density, M, as in the past, is the mass, and V is the volume. So the ratio of mass to volume, or M divided by V. Since there are 3 things in this formula, we can also write it as a triangle. Now it may seem kind of obvious to keep a formula instead of using the triangle, but the triangle is going to be a very useful tool when you have to solve for things like mass or volume, especially volume. You want to put this formula on your formula card. It will be the last formula to go under basics. Let's try a couple of examples. The first is, if the mass of a ring is 68 grams and it has a volume of 13 cubic centimeters, what is the density of the ring? So as usual, we start by identifying what it is we're looking for. What is the density? Now we have one formula that involves density, which we can write in standard formula form or as the triangle. We see that we need a mass, which is 68 grams, and we need a volume, which is 13 cubic centimeters. We can now substitute our values in. Notice that I put the units in. This is another situation where putting the units in is going to be very useful because it's going to tell us what our final unit is going to be. So now when we divide, we get 5.2 grams per cubic centimeter. The grams per cubic centimeter coming out of the formula. So there's our final answer, 5.2 grams per cubic centimeter. Now let's take a look at an example where we're not solving for the density, but the mass. So it says, an aluminum cylinder is measured to have a volume of 5 cubic centimeters. If the density of aluminum is 2.8 grams per cubic centimeter, what is the mass of the cylinder? So, as I said, we're looking for the mass. Now, in this case, we are looking for the mass, but you now have 2 formulas that involve mass, the weight and the density. So this is a case where reading the problem very carefully is going to be important. You just can't go in and try and grab numbers. So by knowing that we're looking for the mass, we now have to go back and see what else we have. We have a volume, 5 cubic centimeters, and a density of 2.8 grams per cubic centimeter. Since we have a volume and a density, we do not want to use the weight formula. We don't have a weight, but we do have volume and density. So we can put down the formula involving density. We can now substitute the numbers in. Now notice in the formula, we end up with one number in a fraction and one not in a fraction, and we have to do a little bit of algebra to solve. In other words, we have to multiply both sides by 5 to get it out of the denominator. If you put it in the form of the triangle, you automatically see that you have to multiply 2.8 times 5. We get our final answer of 14 grams. When we multiply grams per cubic centimeter times cubic centimeters, the cubic centimeters will cancel, which is where the grams come from. And that is now our final answer.